So previously on this channel, we've discussed the area of a triangle. Now, what we didn't talk about when we did those videos was that the area of a triangle that we were finding was for a particular type of triangle. Now, I'm going to call this the acute case. So the case where the triangle in question has three angles which are all acute angles. So we can call this an acute angle triangle. Now, the formula for this one was relatively intuitive. We said that, well, if we have some kind of base down the bottom here that's labeled blue and a perpendicular height h, we talked about the formula being area equals half times the base times the height. Now, just a recap of that, that was because we said when we multiply the base by the height, it's going to give us the area of a rectangle. Now, once we draw this in, we can see that in our rectangle, when we multiply the height by the base, this is going to give us this box around the outside. And we can see that within this box, half of this area, half of the space inside the rectangle is being taken up by our triangle. So this part here, this part makes up half of my box on the left, and then this part here makes up half of my rectangle on the right, or my box. So that was relatively intuitive. We were able to understand it. What we're going to talk about in this video is what we call the obtuse case, where we have some obtuse angle triangle over here. Now, what your textbooks will say if you see them is that they tell you that the area of a triangle formula works for any triangle. So they'll say that even this one here, we have some base over here, and we have a perpendicular height that I've labeled in h over here. And it says, well, it doesn't matter that it looks different to this one up here. The formula is still the same. Now, a lot of the time you just take the word for it, it's okay. But when you actually stop and think about it, it's not really the most intuitive thing to think about, because we're normally used to our perpendicular height, if we look at our triangles, as being something over here, and then the base being over here. That's kind of what we're used to, right? But when it looks like this, it's kind of not as obvious that this formula will be the same. So we're going to talk about why that is the case in this particular video. Now, let's say I still have the base and the height here. What I'm going to do is I'm going to imagine that this triangle looks slightly different. I'm going to add something to it. So I'm going to draw this dotted line down here, and I'm going to make it the same as this perpendicular height that I've got on the left hand side. So I basically just extended my obtuse triangle. I've got my height over here, still the same, and I've got my base over here. It's a little bit shorter. Now, I've extended this, so I have a little bit of an extra length here. Now, my base is B, so I'm going to call this part here A. Now, what I'm going to do is I'm going to consider, I somehow want to relate what I know from how we've done these questions previously to this new weird kind of looking triangle. So I'm going to consider finding the area of this entire large triangle that I've made. Now, what I'm going to do there is I'm going to take my half times the base times the height, because we've seen that work before, okay? But what's going to happen is we have to consider my new base, the entire length here, from here to here, is a length of A plus B. Hope we can agree with that. B goes from over here, let's do another color. B goes from over here to over here, and then the length of A goes from here to here. It's that little extra part. So the entire length is going to be A plus B. So let's do this using our area of a triangle formula. So this is going to be half times the base, which in this case is A plus B, times the height. Now, we are going to do a little bit of algebra here, okay? I'm just going to consider this large triangle all the way over here for now. So this entire big triangle. This is given by my formula of half times A plus B times H. Now, what that's going to give me is down the bottom, I'm going to get half times h, and let me just add an extra step. Remember, when we have brackets in algebra, we can expand these, so the term on the outside is going to multiply by both of my inside terms. So this is going to give me half times, let's write it without the multiplication, half AH plus half BH. Pause this video now if you are kind of confused about how we've done this. You may need to go over some algebra a little bit. Now, remember, what we found here is the area of my large right-angle triangle that I've made, okay? Now, in order to get to this smaller one that I need, we've talked about areas before. I want to subtract this area in here. So I can make my triangle here that I'm trying to come up with a rule for the area by taking my larger area and minusing this little one in here. That will give me the triangle that I desire, this obtuse angle triangle. Now, this is my, let's actually label it here. This is my large triangle area. Now, I want to find the area of this small triangle over here. So, if I go to my small triangle, the formula for the area is going to be half times the base times the height, but the base here is this A, because that is the base of my smaller triangle. So, it's going to be half times A times H. Now, therefore, to find the area of my regular obtuse triangle that I initially set out to find, I'm going to take this large area, which is half times A times H plus half times B times H, and I'm going to subtract half times A times H. And what we notice with algebra is we have these like terms here. So this thing here is going to cancel out with this, because whatever half times A times H is, we're subtracting the same thing from it. Anytime you subtract a number from itself, it gives you 0. So my area is going to be half times the base times the height, where the base is the length of my, the base of my obtuse triangle. So the formula works in the exact same way, even for this weird little case here. But if we take away all the bells and whistles, so everything that I've added here, my formula is actually still going to be the same, where my B is my base of this triangle, and my H is the perpendicular height here. Thank you so much for watching, and I'll see you next time.